Hello everyone, let us discuss the topic Markov chain. This video contains introduction, Markov chain, examples of Markov chain, applications and advantages and limitations. Introduction. Andrei Andreevich Markov was a Russian mathematician best known for his work on stochastic process. A primary subject of his research later became known as Markov chains or Markov process. Markov and his young brother Vladimir Andreevich Markov proved the Markov brothers' inequality. His son, another Andrew Andreevich Markov, was also a notable mathematician, making contribution to constructive mathematics and recursive function theory. Markov process. A Markov analysis looks at a sequence of events and analyzes the tendency of one event to be followed by another. Using this analysis, you can generate a new sequence of random but related events which will look similar to the original. Markov process is useful for analyzing dependent random events, that is, event whose likelihood depend on what happened last. It would not be a good way to model a coin flip. For example, since every time you toss the coin, it has no memory of what happened before. The sequence of heads and tails are not interrelated, they are independent events. But many random events are affected by what happened before. For example, yesterday weather does have an influence on what today's weather. They are not independent events. A Markov system or a Markov chain is a system that can be in one of several states and can pass from one state to another, each time step according to fixed probabilities. If a Markov chain is in state I, there is a fixed probability Pij of its going into a state J. The next step and Pij is called as a transition probability. Example, Markov analysis in an industry with three frames. We would look at a market share of each frame at any time and the share have to add up to 100%. If we had information about how customer might danger from one frame to the next, then we would predict future market shares. This is just an example of Markov analysis. In general, we use current probabilities and transition information to figure future probabilities. Say in the accounts receivable department, accounts are in one of four states or categories. State 1 S1 paid, state 2 S2 bad debit, here defined as overdue more than 3 months, and company writes off the debit. State 3 S3 overdue less than 1 month, state 4 S4 overdue between 1 and 3 months. Note the states are mutually exclusive and collectively exhaustive. At any given time, there will be a certain fraction of accounts in each state. Say in the current period, we have the percentage of accounts receivable in each state. In general, we have row vector of probability S1, S2, S3, and S4. Applications of Markov chain frequently used to describe consumer behavior, used for forecasting long-term market share in an oligopolistic market. Brand loyalty and consumer behavior in the same can be analyzed, useful in prediction of brand switching and their effects on individual market share, sales forecasting. Advantages. Markov models are relatively easy to derive from successional data, does not require deep insight into the mechanism of dynamic change, can help to indicate areas where deep study would be valuable, and hence act as both the guide and stimulator to further research. Transition matrix summarized all the essential parameters of dynamic change. The result of the analysis are readily adaptable to graphical presentation and hence easily understood by source manager and decision makers. The computational requirements are modest and can easily be met by small computers or for small numbers of state by simple calculators. Limitations. Customers do not always buy products in certain interval and they do not always buy the same amount of a certain product. Two or more brands may be brought at the same time. Customers always enter and leave market and therefore market are not never stable. The transition probability of customers switching from an I brand to an J brand are not constant for all customers. This transition probability may change according to the average time between buying situations. The time between different buying situations may be a function of the last brand brought. The other areas of the marketing environment, such as sales, promotion, advertising, competition, were not included in these models.